We are here.
आकाश है सर.
Yes, sir.
20 electrical 32.
Yeah, all right.
Okay. Okay. Uh,
यार ये तो कांट क्रिएट ब्रेकआउट आ रहा.
अच्छा फिर टीम वाइज कर लेते हैं, छोड़.
लेट इट. ठीक है, अपन स्टार्ट करते हैं. आई थिंक वी कैन स्टार्ट. या
So-
विल स्टार्ट फ्रॉम आकाश एंड पलक.
मीटिंग में सबको एक साथ रखना है या फिर जो
वही.
टीम है उसे सीधा. सर बाद में फिर विदाउट
हाँ,
सर
बाकी
विदाउट
सबको
परमिशन
लीव
सब
कर
आ
सकते
जाएंगे.
हैं. बाकी सबको लीव करने बोल देते हैं. अरे ग्रुप में मैसेज कर देंगे, हो जाएगा.
ठीक है. वैसे लाइव तो हो ही रहा है, तो ऐसे भी तो सब देख ही पा रहे हैं, तो नो इश्यूज. अपन इंटरव्यू कर लेते हैं.
हाँ वो
बेहतर
भी
होगा.
है. हाँ ठीक है.
ठीक है. आकाश, पलक, यू कैन स्टार्ट.
One of you can share your screen and just like show the Google Drive in which
Or
you
in
have
case you
posted
have
the
some.
code.
Yeah.
Google Drive or if you have offline videos, then you can show that also.
Yes.
Akash.
It's a Palak doing this.
So, sir, is my screen visible?
Yes, it is.
Yes.
Go ahead.
Okay.
All the best.
So, I have to explain code and video both.
You can just show it in normal scale. Maybe that Google Drive would take in it. This
Only the video.
largely you can just go through the videos. Not all. Yeah, you can just go through the videos. But
Make it quick. Like yeah, your videos are small, so just like glimpse of videos. You can like speak about it and just show us your end result.
yeah.
Okay.
You might have also these things downloaded, no? So that would as well, like in
Yeah.
case you're interested.
So, in the first part of first question, we are using three push button switch to like control the three LEDs, and we are not using the Arduino. And we have done the same question using Arduino also. So in this demonstration, we are just pressing the switch, and for that duration, the LED will be on. Yes. And we are using resistors in parallel to decrease the resistance because each resistance is of 2.2k ohm. Yeah, like this.
Okay.
Okay.
Yeah, that works.
Yes. We have used white light because we did not have yellow, right? And we
Okay.
did not have RGB
Okay.
also.
All right.
That is not the
Yeah, it's
problem.
all right.
And same thing we have done using Arduino also.
All right.
Solution for problem statement number 1 which with LEDs, red push button and RDP. When I push this button, red light goes. When I push this button, white light goes. And when I push this button, green.
Yeah. So same thing is happening with Arduino.
You are taking just the
And
digital inputs, right?
yeah.
Yeah.
And for the part 2, we are giving the delay in our code, so it is like automatic.
Solution for question number 2.
We are giving 5 seconds delay for each LED.
Traffic light.
Okay.
And we have connected 3 PWM pins to input of LEDs. Record of LEDs are connected to resistant, and that is connected
Is
to
it audible, the video?
Yeah,
Yes,
yeah.
yes, yes.
Okay.
the negative of these resistance are connected to ground of Arduino. We have kept
Yeah, I
five
think we are good to go.
selected.
I just having a one question. Like you are using three digital output pins, right? Here for this one.
Yeah. Yes,
So
sir.
can we do it with one
So
digital pin?
Yes, sir. Yes, sir. We can do it.
How can we?
So we can use RGB LED.
No, I meant ki you'll be having three LEDs and just one output from the Arduino.
yes, sir, we can just sort with everyone, every LEDs, and just keep three press push button uh, uh, connected to the ground. So when we push one push button, then one LED glows,
Huh.
and when second, and like that.
No, like what understand the question well. Basically, what I want ki, let's say I have this Arduino. I just have one jumper wire that I want to like two jumper wires. The first one would be the ground. The second would just be a signal pin that I'll be getting. Maybe it can be analog as well as a digital. Can we do this thing with just that one pin? There is no push button involvement here. Does that make sense? Would that be possible? Just I largely wanted to understand.
No, sir, blinking is not possible, I think.
In
Do you
case,
want to repeat question?
yeah. Basically, what I want, I have this Arduino and I want to connect these three LEDs in series, let's say, and I'll just like I can include anything between these. I just want a deal to attain that delay with that one particular output. Maybe something sort of a blocking thing in between, like we have one LED, then we have second LED, then we have third LED. We'll just keep something in between that will be doing, or else we can just do any manipulation in code that would make that work out. Mm, yeah, probably we can
Sorry,
do it.
sir, Dito.
Yeah, largely I think that way we can't do, but yeah, all right, let's move on. Next thing.
Okay.
Mm.
Uh, so, sir, in the question two, we had to use an
Yes, yes.
LDR, and when the light will be on, like during the daylight, the LED should not, or the street light should not turn on, but in the evening time or the night time, it should turn on. So, we have modified the code a little. What we
So
have done is that we have added a rotating solar panel, like instead of a basic solar panel, we have rotated it by using the mechanism of solar tracking, so that it will rotate along with the sun 15 degree every hour. But here we have given a delay of 1 second because we want to show it in a sample. So it will rotate 15 degree with every, like till the time the light will be shining on LDR. Okay,
Okay.
with its rotational energy trapped and restart it.
like that.
Its day
It is rotating by
lights is
15
showing
degree
on LDR.
every second
It starts rotating
till the light is shining on LDR.
15 degree. Constant. We can increase its
Why do we want to
angle.
rotate it? I didn't get that.
Because we want to collect more energy from the sun, like in the
Okay,
same
sun will
time.
be moving,
Yeah,
so basically
yes.
got it.
Along with the sun, so the more light will be incident on it, so it will collect more energy.
Yeah,
Basically,
makes
this is
sense.
a solar tracking mechanism.
Okay,
We can
and
increase
you'll
its
be
time
glowing LED
like
when it is night or maybe the dark.
Yeah, just a minute. Okay.
the light
Like if we block the light
close
when
the
it
light
will be evening or night time, it will turn
it's
back to its
rotating.
original position, and it will stop till the next day, and again sunlight will fall on it. Then it will again start rotating, and see in the night time the LED or the street light is turning on. So we have done this modification.
It's back
Uh, I
Okay.
think I think that sensor that you had was a digital module, right?
Yeah.
So what you are just checking key when that it gives a zero output, so you are just you are just regulating it. That is the way you are following, right?
Yes, sir.
Hmm. All right. Akash, any other questions that we have?
No, not for this part.
All
Okay,
right.
it's good.
Okay, sir. Okay, so in this third question, we had to create a track, like
This
railway
will
gate, right?
this is the solution of problem statement number n goes, and when train goes, then barrier gates should open. I have kept 50 centimeter as a train distance because it is not possible. Large ultrasonic sensor is not capable of that. So
So we have kept the distance below 50 centimeter. If the object comes in that range, the gate will close. After that, the gate will open.
there is no obstacle in front of ultrasonic sensor. When I keep my hand, it
Yeah, so gate
closes
is
the door.
closing.
When I remove my hand in, it opens the door. When I keep my
What is the
hand,
range of ultrasonic sensor?
So 33 centimeter to 400 centimeter.
Akash, anything else?
How much can a servo move? Like what angles?
Sir, it's a 360-degree rotation servo motor.
So you have 360-degree servo motor, right?
Yes, yes, sir.
And there are another motor also 180 degree. That servo motor can only rotate to 180 degree, 0 to 180.
Can you just largely tell how a servo works? Like you have
Okay.
three pins inside it. Just
Uh,
a briefly you can mention.
Okay, so sir, because this is a 360-degree rotation servo motor, we are controlling the time till which we are giving it a high pulse. So, like we for 90-degree rotation, we are giving it 85. We are setting a counter for the time from 0 to 85, and in that duration of time, we are giving it a high pulse, so that it is rotating by 90 degree. And so basically, we can set the angles of rotation for this motor.
Uh,
So,
we will, yeah, we'll set the
uh,
angle of rotation with the pulse that we are giving. Like
Yes,
for
yes.
a particular amount of time, when we'll give some particular amount of pulse, it will rotate to a particular angle, right?
Yes.
Is there any way how can we exactly calculate okay for this particular this amount of pulse it should rotate to this particular angle? There should be a formula kind of thing, right?
so in 360-degree rotational motor, there is not any such formula. We can just control its speed
Hmm.
by, like, if I give 1.5 milliseconds high pulse in
Yeah.
20 milliseconds, it will stop, and when I keep it like 1 millisecond per 20 milliseconds, it will go backward, and if I give 2 milliseconds per 20 milliseconds, it will rotate clockwise.
Yeah. All right. Okay, so
Okay,
that's
And
okay.
yeah, we are also turning on an LED when the gate is closing.
all right. That was an add-on to this. Yeah. Akash, anything else? Arshit, Tanisha.
No, sir, it's all right.
Yeah. You can move to
It
the
is
next
fine.
problem.
Yes.
Okay, so in this question, we had to calculate the speed, acceleration, and the distance of object in front of
this is
ultrasonic
solution
sensor.
for problem statement number 4. So keep an object in front. So if I keep an object in front of it, so like distance and speed and acceleration also. When I move it like this, it's showing speed, distance are changing. I have kept acceleration as 0, and if I just change acceleration also like this, it will show acceleration as
So basically, we are with the help of two distances, we are calculating first speed, and then again we are like varying the distance and calculating the second speed. With the help of the two speeds, we are calculating the acceleration. So if the object is not moving, then all the distances are same. Speed is zero and acceleration is zero, as we were seeing it initially in this like demonstration.
Okay, so this negative acceleration is retardation, right?
Yes, sir. Yes, sir.
Okay.
Can you show the LCD one for this one? Like,
Yes, sir.
yeah. Can you show the acceleration in the LCD?
Okay, okay, sir.
Solution for problem statement 5, part 4, in which we need to print acceleration, distance, and speed of an object in front of ultrasonic sensor on LCD module. So, like I have placed here a copy, so it is showing the distance. If I move it towards ultrasonic sensor, acceleration and speed are also.
We are getting a negative speed here because the d2 is less than the initial distance. So basically, we are subtracting d2 minus d1. So we are getting a negative speed.
Generally, generally it's
So
calculated
I
with the respect of the, like, it should be calculated with the respect of ultrasonic, right?
Yes, sir.
So in case it's going towards the ultrasonic, your acceleration is positive, but your speed is negative. So won't that be like deceleration?
Sir, if it is going away, if the distance is increasing, then the speed is increasing in this case.
So what you did is like if it is going backward, then it's a positive speed.
Yes, sir.
But generally, like if you want to measure the speed of for a vehicle like coming towards you, so will you place it like in front of it or behind it?
Okay, sir. That can be changed if like
Okay,
in the formula.
other than like this normal application of measuring the speed, where else can the ultrasonic be used?
Sir, ultrasonic can be used like in measuring the depth of some like for a tank we can like measure the depth till which the water is there, and then we can know when the tank is empty or full, like
Okay.
that.
And anything creative you can do with ultrasonic, any idea?
Sir, in the sonar system we can use it, like in the ships the sonar system is used, and we can like
Yeah,
calculate the
like
depth of
not
the.
something which is already available, something
Okay.
innovative, like just like something that comes in your mind right on the spot, like something you can do with the ultrasonic, which will be helpful and isn't done yet, or like
So we can create an automated like drone in which we if we set this sensor, and anything if comes in front of it, then it can itself change the direction of its movement.
okay, okay. You can show the like other LCD um, the videos as well.
All the
Yeah,
LCD videos, right?
I think largely we
yeah,
are fine with na Akash. We'll have less
yeah.
time.
Any more question or anything, Govind?
Yeah, I feel this LCD module, how you have integrated it, like you found a pin mapping to it. How did
Yes,
you
sir.
do
Sir,
it?
actually, there is a problem with this LCD module. Actually, this LCD module
Let Palak
will.
explain first.
Yes,
Yeah,
yes, sir.
Palak.
Yes, sir. Actually, this was not matching with the Tinkercad module. So, sir, Akash had like mapped the pins according to the like data sheet of this module.
Okay, so basically you found us how many inputs that you are using for this particular LCD module?
It's a four input.
Four input is enough.
Yes, sir. Said
Mm.
eight can be used, but we are using four.
Why do we use eight and why do we use four?
So four.
Yeah, Akash, go ahead. I think your voice is cracking.
So, so
Is it just for me or for all of us?
No, sir.
for
It's a problem. Okay, you can write in
for
chat
big
box answer.
Yeah. yeah, largely we are good to go. Nicely done. Like I feel within this particular time, I feel you have done great job.
Sir,
Nice work.
sir, but he
Yeah,
has
yeah, he'll
explained his
explain
method.
definitely, no issues. Like he'll write in chat, no? All right.
Okay, sir. Sir, do I have to show all these three of
No, no,
LD
no. It's
also?
fine. It's
It's
fine.
not
We'll just
needed.
check and we'll just check the detailing inside the code. How you have written the code? You have written the functional code as well, no? You have created a good amount of functions and then
Yes, sir.
you have written it. Yeah, yeah, yeah.
Yes, sir.
That was important. All right. Chalo. All right. Nicely done, Palak and Akash. We can move on to the next team.
Thank you.
Thank you,
Next
sir.
team is Amal Shibu.
Hello, good evening, sir.
Yeah, yeah. Amal, all the best. Go ahead.
So, sir, this is my model for the first problem.
Yeah.
So, here are in the model there are three LEDs, red, yellow, and green. So, initially the green is turned on. I have a model. I have simulated this same thing. So the code is like initially when the model is turned on, the red will be initially in red. So when we push the button, uh, so after the timer will start. So after the timer ends, it will shift to the next LED. So and the timer will start again. So when we push the button again, it immediately resets the timer and shifts to the next LED. When
Oh,
we
you
push
have
it
implemented
again,
this way. Yeah, yeah. Nice.
yes, sir. And then it again shifts to the next one. So the model also works like that. So here is the button. It's the timer. So when I push the button, it immediately resets and sets to the next LED.
Yeah, yeah. That's cool.
That's
You
for
are
the
you are not using that module, no? You are just using the LCD and you have your custom potentiometer.
sir.
You are not using the module that we
No,
gave.
sir.
You had
Uh,
you just bought the LCD module.
yes, sir.
Yeah, yeah. All right.
So I will go to the second problem, sir.
Any other questions that we have around first one?
No, it's fine, I guess.
Yeah, yeah.
Okay, for the second problem, uh, so there is a this for measuring the intensity of light with photoresistor, and if the intensity is very low, if the intensity is very low, that is less than 10 or something, then the light will turn on automatically, and when the intensity becomes high, then turns off automatically. So
Uh,
the the internet issues.
yeah, yeah. No issues, no issues. We have seen
Okay,
the
sir.
video.
So
What values you are getting in intensity, like in LCD?
intensity, sir, I initially thought of a formula with finding the LEDs of the light and all, but it was coming out wrong. So I took the analog reading only, sir.
The variation in your analog reading is very less, I guess. It's just
Yes, I
something
think
is
so.
16 is showing when the light is falling and like 6 when the light is closed.
Yes, sir, I think it's the issue with the photorest or something, sir. In the simulation, it's coming different. It's very different, but in the real life photodiode, it's coming.
No,
simulation.
actually,
Yeah.
you have this photoresistor. So you have to connect one potentiometer or the resistor so that you can get the variation, right?
Oh, okay,
But
sir.
there is a very small variation, 16 to 6.
Right now, the photoresistor that you are using, you might be doing the voltage divided circuit here, right?
Yes, sir.
Ahmed?
With
So
the
what is
resist.
the resistance that you are using for that?
Sorry, sir.
What is the resistance that you are using as a voltage divider?
Sir, I think 2.2K, sir.
Why do you feel that's the right value? Or how will you judge that that's the right value? Largely.
Uh, the intensity we got. Sir,
Uh,
Okay. You are getting a minimum 6 value and the maximum 16, right?
yes, sir.
So can you increase this variation without
which
changing the
variation?
circuit?
That variation we want to increase. How will we do that?
So by decreasing the resistance,
If we'll
No,
decrease the
no.
resistance,
If we will not change like this circuit, is there anything like how you will increase the variation without changing circuit,
uh,
or
sir,
only
we could
by circuit only you can change the variation?
no, sir, we could incorporate that into the code, sir. So we could use a map function
Mm-hmm. Mm-hmm.
to change the range from this range to the next range.
That's what you have to do here, okay, to
Yes,
increase
sir.
this variation.
Yes, sir.
Okay.
what happens when the light falls on this LDR? Does its resistance increases or decreases?
Its resistance decreases.
All right, move on.
Okay, sir. So this is the railway crossing problem, sir. So here is a ultrasonic sensor, LDR. So I have done the simulation part here. So in the simulation, it measures the distance as well as the status of the gate. And if the I took the minimum distance for the gate closing as 126 centimeters. So when the train comes at a distance less than 126, the gate close and the LED will uh, turn on, indicating that the train is closed. So when the distance in the simulation 2, when the distance is less than 126, the LED is glowing. And in the simulation part 2, initially the distance is 253. So the gate is open. The gate is in the open state, and the LED is not glowing. So when I put my hand close to a sensor, we can see that the gate is closed and the distance is measured as 3.2, very low, and the LED is also started glowing. When I remove my hand again, the distance is measured as 256 and the gate is open. LED also stopped glowing. The gate is also open. Sir,
When you wanna ask
Yeah,
me?
yeah. Can you just tell for this particular LCD module you are using 8 bits or 4 bits?
4 bits I think.
What is the
For
difference
bit,
between them?
yeah.
8 bits we can incorporate more values, I think. Hello, sir.
Yeah, like how did you write that code in your Arduino ID? Arduino ID.
Sir, you want me to take the code?
Like from before this task project, did you see uh, that working of this LCD module, or just write the code, write the code? Like
I
what
just
argument we are passing in this LCD crystal object?
uh, Sir, I knew something from the workshops, so I just started writing codes.
Okay. Okay, no problem.
Amal, you are using this
Yes,
servo.h library for controlling the servos, right?
yes, sir.
Is there any other way that we can do this without using this header, without using the servo.h header?
Probably, sir. I don't know, sir.
All right, no issues.
Okay, sir.
Okay.
So, for the fourth problem, just to measure the distance, speed, and acceleration. So, this is my model, and here the simulation. So, initially, you can see that the speed, acceleration, and distance are zero as there are distance is 140, speed and acceleration are zero as there is no movement. When we start moving, we can see that the speed and acceleration are slowly changing. So in this problem, I took only the positive values. As when we measure a car or something moving, we only need to find the magnitude of the quantity. We already know which direction it is moving, so I took everything as positive. So here, when I put my hand, initially the distance is 250. When I put my hand, the distance is decreasing, and
But the acceleration, like it is always zero.
acc-
Why?
acceleration because it's moving very slow. That's why. But when I move fast, it's changes. But since the Arduino is very fast, it is coming and clearing very fast. So if something is moving constantly in a constant acceleration, then it will pick that up and show it constantly.
Okay, can you just start this video from the start? From the
Okay, sir.
beginning. Yeah, no, do not pause. Okay.
Okay, sir. This is a model. So initially the distance is measured as 140. When I
No, no, no.
started,
Hardware model.
okay, sir. So initially the distance is given as 256. So when I place my hand over, it's now showing 10, 10, 9,
Yeah, that's
9.7.
what I'm asking. Like it is showing 0.00 and 0.01 only.
So,
So it should be.
so everything here is in centimeter per millisecond, millisecond and millisecond square. So that's why if I when I move my hand in a very in a pacey way, then the speed is picked up. But since the Arduino moves very fast, it is clearing out fastly. So if something is moving with constant acceleration or increasing acceleration, then it can pick that up and show it constantly in the screens.
Okay, and no retardation is showing, right?
Sir, I took everything as positive, sir, since
Okay,
we already know
okay,
the direction.
okay, okay, no problem. You can proceed.
Okay, sir. Sir, I have only this much, sir.
Yeah, yeah.
Okay. Of have you seen like
Right.
in malls like the door opens automatically?
Yes, sir.
So consider a situation where like you want if a person stands right in front of the door should open. But
Yes, sir.
in case a vehicle or something which is not a living thing stand in front of the door, it should close. What are your ideas? Like what should you do in order to implement the
Uh,
same thing?
we could use the proximity sensor because it only picks up the heat signature. So, in case of a vehicle and all, there will be no heat signature. So, if only a person, only a living thing comes before the door, then it will pick that up and changes the output signal into high voltage. So, that can trigger the opening of the door.
Okay, anyone has anything else to add?
Yeah. Can you explain, like, in brief, what is the working of this ultrasonic sensor?
So, ultrasonic sensor, when we give a high voltage to the trigger of the ultrasonic sensor for at least 10 millisecond, then a short burst of of high frequency ultrasonic waves are given out. So it when it hits something and comes back, and it is received by the sensor, and it is received by sensor which during the propagation time, a high voltage is given out by the echo, through which we can and when it hit backs, the high voltage stops. So we could measure the duration of the traveling of the ultrasonic uh, sound waves by measuring the duration of the uh, this high frequency given out, how high voltage given out uh, by the echo. So in that way we could measure the distance and
Okay, no problem. Like, a small formula, from which formula you calculate the distance.
yes, from the distance, first we calculate the duration by that
Hmm.
high voltage thing by pulsing function. Then we multiply it with the velocity of sound, which is approximately 0.34, uh, I think, and we then divide it by 2 because it it travels 2 times the same distance. It goes and hits the thing and comes back. So 2 times the wave is traveling. So we have to divide it by 2 to get the distance.
Okay. Okay.
Okay, sir.
I don't think so. Anyone has anything else? Govind?
No, you can move on.
Yeah. No. Nice presentation, and you did it alone.
Thanks.
Good work.
Thanks.
Now we can have the next team. That's Team Phoenix or Phoenix. I don't know how to pronounce it, but Team Phoenix.
Yes, sir.
Okay, you can present your screen and start the presentation.
Okay, sir. So, sir, this is our first problem. Um,
Yeah, 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 yeah.
Yes, yes.
You
so,
don't need to go through the entire
so
video. You can explain and just show the output. Okay.
yes, sir. So basically, this what in the problem statement one, what we understand is that we should using these devices. I think that we are given the problem that to mimic the working of a traffic light that we are seeing in our streets. So on that principle, I have assembled this circuits, and you can see, as we can see here. Uh, so these are the devices. I mean, these are the components I'll be using, and then so this is my connection, sir. I have connected red, yellow, and green as I have been told to uh, glow this bulbs in a sequence. I have programmed it accordingly. First, the red LED will glow, and then there will be a delay of 5 seconds, and then the control will move to this yellow bulb, and this yellow bulb will also glow for about 2 seconds, and then this control jumps to this green LED, and then there will be a delay of 4, and then the loops continue continues. And before we start the loop, we are using this push button. When I press this button only, then only this LEDs will glow in a sequence. So I have the code for this. I have written this code here. First, I'm declaring these pin numbers, and then I'm declaring using this push button, a button number, and this is the variable where I'll be storing the.
Before this, can you show the output? Like we can understand the code, no problem.
Okay, sir. Okay. So this is the output.
So why this LED is like not glowing that much?
So can you please repeat? I didn't hear you.
Why this like intensity of this LED is not like? Can you
So
increase the
because
intensity?
the intensity of this LED is low
Yes.
because I am using the uh, this resistor 10 kilo ohm resistor, sir.
Yeah. So can you increase like the intensity?
Um, no, sir.
If you
I don't
want to
think I can
increase what
increase it.
if you want to
Yeah.
increase the
What will
intensity,
you
how will you do?
do?
If I want to increase the intensity, uh, basically I'll be using only like one or two register, and I'll be connecting uh, this register to the anode of this LED, sir. So that way we
So
can
will you connect in parallel or series like those resistors? In
uh,
parallel or
I'll be connect
series?
I'll be connecting in series, sir.
In series. What
Yes,
will
sir.
happen like if you will connect these sensors, sorry, this resistor in series? So the overall resistance will increase or decrease?
So the overall resistance will be overall resistance will decrease.
Decrease. Okay. Overall resistance will increase. Okay, when you will connect in a series. So, to increase the intensity of this LED, you have to connect the resistor with the parallel. Okay, in parallel.
Okay, sir.
All right, let's move to the next thing.
Okay, you
Yeah,
can proceed like
you can go to the next one.
this.
So like I don't have to go through the connection part, right?
No, just the output and like what you did.
Okay, sir. So in this solution number two, I think we are told to mimic told to mimic the smart street light, and for that we'll be using this light dependent register, and using this we can implement a very smart street lights in our street, because the principle working uh, of this LDR is something like that. Like when a sufficient amount of light falls on this register, as you can see here, then the LED connected this another LED will not glow because it is receiving an amount very quite a very good resistance. Uh, that's why this LED will not glow. But during night time, or it's a evening time, when this LED senses no light, or when it becomes completely dark, this LED will this blue LED will glow, because this LED is not getting much of the light intensity, sir.
So this is your LED or photoresistor.
So this is the LDR, and this is my LED
Yeah. And
photoresistor.
LED and photoresistor both are different things.
So I think that there is nothing much different between these two. One uh, works as our ordinary lights, and the other thing,
LED
other
is the light emitting diode. Okay, a
yes,
photoresistor cannot emit that light. Okay.
yes, sir, yes, sir.
Okay. Now you can
So
proceed without.
yes, sir. When the brightness is very high, the resistance of this photo resistor will be small, sir.
Okay, you can show the output.
So the output.
So yes, you can see this is my um
What happens when we put the light on this LDR? Does its resistance decrease or increase?
so the resistance will obviously increase.
Resistance for LDR would increase.
Yeah, resistance for the LDR will increase. Oh no, sir. The resistance will decrease when the brightness is when we give the brightness a sufficient brightness. The resistance will decrease. Like, sorry, sir.
In case we wanted
Yes, yes.
to use it, then what will like we want to see when the light increase should increase
Sir, your
and
voice is not clear.
then
I
the
Sir,
output
I guess
Govind
can't.
sir,
you're
repeat
be
some.
turned on.
Sir, your voice I can't hear you, sir. I can't hear you, sir.
All right,
uh,
let's move on.
now it's clear, but yeah, move on to the next video.
So, sir, by this in this problem number 3, I think we are to automate and the smart gate, which we'll be using in the trains in the railway tracks. This will be like the working principle, something like this. We have this and this uh, ultrasonic sensor when something or an object or any say suppose train is coming near uh, to this register, I mean to this sensor, then this red LED will glow and it will alert the people that there's something is approaching towards this. And then what will be happening here is that uh, not only this red LED will glow, but this um, servo motor which is connected to the same to this breadboard, it will be when the object is very near, say about 20 centimeter. I have programmed it for 20 centimeter or less. Then the this red LED will glow, and this servo motor will also uh, starts and it will eventually close the gates. So this is what I know. At least I understood about problem number 3, sir.
Yes, right. You can show the output.
Can you just quickly
Sir.
Just play the video.
Okay, sir. LED is also blinking, which is saying that the object is very near from the sensor. So this is my output, sir.
Yeah, you have actually made a fan out of it.
Yes, so you are not able to rotate the servo motor to 90 degrees.
Yes, sir. Because I somehow programmed like this for the servo motor. Like
We are using the
I'm like
servo.h
if the
library. Ram. We are using servo.h. Can we use anything instead of that?
Actually, some student I'm just logging
yes, sir. Can you please repeat? I didn't quite understand it.
You are using
So you are writing this
servo.h.
code on 180 degrees servo motor. I think.
Oh, yes, sir. I'm using like 0. I'm starting from 0 and 90, and then when the LED is high, it will be starting from 90 degree to 0. It will
You
move
are
from
not
90.
audible.
Yeah, yeah. Okay.
So like when the
You
distance
are
is less
yeah.
than 20 centimeters, the LED will not glow, but and it will remain at this zeroth position and 90th position, zeroth position. It will not move. But when the LED is high, which basically means the object is very near to that sensor, the servo will rotate that from 90 degree to 0, basically. So this is how I programmed, but I actually don't understand what is happening with my with the servo motor I got. It's keep on rotating 360 degrees
Okay, okay.
actually.
Yeah,
Okay.
it was the problem with some servos.
Yes.
Okay, you are using the servo.h library. Can you use any alternative for that?
um any alternative
Like
servo
without
motor?
using this library, can you operate the servo motor?
uh can,
Or simply we are asking like the basic working of the servo motor.
sir, I think we can, but I don't actually
Or it is
yeah. So should I move to the next
Yeah, yeah.
problem, sir?
yeah, quickly, quickly,
Yes,
please.
yes.
So sir, this is the connection. I mean, this by problem number 4, what we understand is that what we understood by this problem is that we have to like measure the distance and also uh, the speed and acceleration of the moving object. So here in this here in this circuit, nothing is here, only the Arduino and one ultrasonic sensor and this connections here. But I'm showing you the outputs here, as you can see. Uh, so this problem in the serial monitor now, and then when the acceleration will be detected uh, by this sensor. So let me show you in the serial monitor now. So this is my program for this problem number 4. This is all the as we can see now, it's sensing the distance, acceleration also, distance also, and then in centimeter the speed. So it's basically working. So that's all with this. Thank you. So I think this is the output, sir.
Okay.
Yeah, yeah.
And were you able to do it with the LCD screen?
So actually, like I tried it, but the one which I have learned in the workshop is very different from the LCD I've got. I was very stuck for one day assembling that part, so I haven't done that part, so LCD part number 5.
It's okay. Good work. You tried
Yeah,
at
yeah.
least.
No, actually, your
Yes.
videos are quite good. All right, let's move
Yeah.
on.
Thank you for your presentation. Next team is Team Blue.
Team Blue.
Thank you, sir.
Yes, sir.
Yeah, we'll start.
Yes, sir. Advay will present from our side.
Akshat and Advay.
Yes, sir. Like as we don't have the all equipments, so we just do what we have with that.
Yeah,
Yes,
yeah,
you
that's
can
okay.
show what you
Yeah,
have.
so due to time constraints and all, we only did question number 3, question number 4, and their implementation question number 5 with the LCD screen.
All right.
Okay, yeah, yeah, cool. Go ahead.
So
Good afternoon. This is our model
were you all able to hear the voice from the video?
Yeah,
Yes,
yeah.
yes.
Okay, okay.
Yeah.
I'll just play that then for now.
for the railway crossing train sensing problem. So we have used a ultrasonic sensor, a servo motor, and a red LED as a alert signal. As for the demonstration, assuming that this book would to be the train, so when it comes closer, after a certain distance, the gate will close up, and the red LED will alert LED will be turned on. Also, then once the train has left, there is a certain delay that we have specifically set, after which the gate will again open up to ensure the safety of the crossers. So once again, as soon as it is in a certain distance of the station of the crossing, it will close, and then once the train is gone, it will open.
Advay, you are controlling the servo from 0 to 90 degrees, right?
From 90 to 0 actually, but yeah, I
Yeah,
just
yeah.
based on the orientation that I put on the table,
Yeah,
yeah,
yeah.
yeah.
All right, all right. So, like, what you are using the servo.h library for that?
Yes, sir.
Is there any other way to do that?
Yeah, so from our understanding of what header files are, so for example, we use like we have all the servo printing. One second, huh?
Hmm.
Yeah, my servo dot write. So that's a function that must be defined in the servo dot edge. So and since it's all like we have only connected one digital output, so I guess based on that we could use some pulse width modulation, and like there must be some like if we had a better understand if I had a better understanding of the servo, then I could think. But
Yeah,
yeah, some there is some underlying function that is doing that. So maybe we could have written some similar logic to that, and we could have done it.
yeah, yeah. Works. Next thing maybe, or any other questions that we have around this?
No,
No, sir.
no, it's fine.
So, like, you have used here in this one, you have used an ultrasonic sensor, right? So,
Yes,
can
ma'am.
you think of anything else other than ultrasonic sensor? Like, you're not given an ultrasonic sensor. What else component can you use to make the same system? Can you think of anything?
Yes, ma'am. So two things came to mind. One could be along the track of the train, right? At different points, we could have some sort of lot. So basically, both are along that logic only. So having different kind of trigger points along the track of the train. So when the therefore like one will trigger, then the other will trigger as the train is coming closer. So based on that, it can open the and close the gate in advance. So for that, we could use maybe proximity sensors and that, or even if we could have a laser light that is just bouncing back from a mirror and coming back. If the train blocks the light, it will not rebound back. So again, just different kind of triggers for that kind of thing.
Okay, I have a question. I will provide you some IR module, IR sensor module. So, is it possible, like, to solve this problem with on those modules? And how many modules you will use?
So
To,
infrared module.
yes, I
So
have
one second.
gave a demonstration of these modules in workshop, right?
Yes,
Yeah.
Akshat, any idea?
That's right. What am I idea about? Yeah, Modi,
Yeah, it's okay. Your solution was good for the railway one. So yeah, you can move ahead with the next presentation. Next
Okay, so
video.
yeah.
So good afternoon. This is the demonstration of the fourth module. So where this is the ultrasonic sensor, and this is our LCD screen that is giving the output of the current distance. So uh, yeah, and so this is the updated distance that is there. So it's showing the distance say at 15 centimeter, and as we go further, 18, etc., etc., 23. As for the acceleration and velocity,
Yes, I'll just pause it. I'll play back the rest of the video later. I'll just at some the distance is right now showing some quite a large value also. I think that was due to the book that I was keeping. Like I was having to film so I think it was not actually blocking the actual cone of the ultrasonic sensor. So it
Okay,
was like
okay, no,
rebounding
no
off my
problem.
wall
We
or
can
something.
understand that part.
Yeah.
we are also getting it. We are also getting constant readings on the uh, serial output. The velocity and acceleration is inherently quite inaccurate.
Yeah, that's one thing that me and Akshat. So we are here. We're using kind of in the code I could show you. So can I go to that? Is it okay?
Yeah, yeah.
Yeah. So the method that we were using, yeah, this is the one. So we were using functions like float. So getting distance. Just one second. Yeah.
Uh,
Uh,
can you just
yes.
zoom in the code a little bit?
Yeah. Yeah. Sorry. Sorry. Um, is it okay?
Yeah, yeah.
Yeah. So we were using functions for getting the distance using the ultrasonic parts. This is just the standard kind of thing, and we were also having a three global variables. So distance final, velocity final, and acceleration final. So this returns the distance. Then the get speed is calling both of them one by one, and using the time difference of the delay time here, we are calculating the speed, and then we're returning the speed to whatever we'll call this, and we're also again updating velocity final, and then get get acceleration calls speed two times, right? For two different instances of that. And over here, same thing, we were also updating the final thing. One more thing is that so we kind of, if you notice, this code is just continuation of the servo one. So we actually just integrated both the question number 3 and 4. So that where we could get the speed, distance, and acceleration of the train itself, like in that sense, right?
Yeah.
Yeah.
The
Um,
yeah. Go ahead.
and also just so that's for that reason we had chosen a d1 minus d2 as the speed because it was coming closer, right? Uh, to keep the speed positive, and then acceleration will always just be this. So yeah. What
Yeah.
I was talking about, yeah, yeah, sorry, you could.
So
Yes.
yeah, yeah. Go ahead.
Yes.
Uh,
What were you saying?
Yeah, one thing that
so good afternoon.
we
Stationary.
one thing that we noticed, so in these serial outputs, etc., the acceleration and speed values, especially if you keep the thing very constant, if you give just you don't move the object, right? At least in the implementation that we found, like that we set up with the code, we were getting a lot of inaccuracies when the object is stationary. So I think the logic that we could think of that is that the ultrasonic sensor is very slightly inaccurate, maybe, I don't know. So due to that, it's slightly the distance actually changes even when you just keep it steady, even in the simulator Tinkercad, the distance changes slightly, and the slight changes of distance are quite random, and two consecutive distance changes, so it'll think that it's actually moving, and there's some velocity there, which could sometimes be whatever, and then two different velocity changes, so it kind of just the error kind of compounds into, so the acceleration can be quite random when the object is stationary. That's what I.
Yes, sir. Like here we have find that if our object is constant, then also it is showing that acceleration
Yeah,
something like 1 point something acceleration it is showing. So it may be because of that distance is inaccurate calculated by the an ultrasonic sensor.
yeah, and then it was getting compounded all throughout. Overall, when the in the part when I had it like slowly moving towards that time, I think it was giving a proper kind of.
As for the acceleration, 18, etc.,
Like
etc.,
sir,
will
here
be filled.
the our this object
As
is
for
constant,
the
so also
acceleration,
it is showing acceleration sum. So it may be
No
because of
problem.
the distance is inaccurate.
Yeah. So this is your like last solution, right?
Yes, sir. Like
Uh,
for second solution, we don't have the IR sensor, so we are not able to do that.
IRNI,
And
yeah, LDR,
sorry,
LDR.
LDR.
LDR sensor.
Yeah,
Okay.
So we are not able
and
to do that.
overall we just I like overall timing was the issue. Like,
And just we write the code for that for some.
yeah,
Yeah.
they
No
only like
problem.
sort of
No problem.
designed it in the simulator. Yeah.
That's okay. The code is nicely written. Yeah,
Yes.
it's good. In case Harshad, you have anything to ask?
No, sir. No, sir. No, sir.
Yeah, it's good. If you hit all the components, you would be able to make it. I believe that. So yeah,
Okay,
it
sir.
was good overall.
Thank you, sir.
Thank you. And next we'll be
May we
having
stop? Okay.
yeah, yeah. Next we'll be having team Krypton division.
Good evening, sir.
Good evening. So one of you can share the screen.
Yes. In this video, we see the simulation. So is it audible?
Yeah, it's audible.
Okay. Of the working of the traffic light signal. Without any manual assistance, the traffic light will be automated.
You
At
can just
first
explain
step,
it yourself and
red
just
will
show
glow,
the
then
output
green.
because
The
it's
glowing. Okay, sir. So, should I present the Tinkercad thing?
it's not needed actually. You can just
Okay,
say
okay.
it orally and just show the output.
Yes, sir. So, what we did is that instead of three LEDs, I have put four LEDs. So it's like when we don't press any button, it will be automated. First red, then yellow, then green, and so the cycle will proceed. And but when it is like when in case it's not working, like in case the automated system fails, then what happens is that the white LED will glow, and so to indicate that these are not working, and we can manually run it. So that's why I put an extra one, and also
How exactly you will find out that the system is not working?
yeah,
I
like
didn't understand that part.
okay, so I have to show my code. Dear. Okay, so in my code, what I did was that I have given three push buttons. So in the first loop, it is like if push button one is like high and others are low, then we'll follow certain operations and it goes on for other things. In the else part, like if all the push buttons are zero and so on, then it will be automated by itself. But in all these other if else part that we had initially, we would on the fourth LED to indicate that it's like it's getting automated. But in case anything fails, like in the system, then even this LED, like this LED would glow so that we can do with the push button thing. So
Um,
should I show the Tinkercad one? So
okay, if
explain.
you want to, you can.
Okay, sure. Okay. Is it visible?
Yeah, that's visible.
Okay, so let's start the simulation. So it's automated. So this bulb is glowing to indicate this. Now if we press a button, everything else like gets closed manually, and then again it gets automated. And this is the code that I've written. It's quite big.
Yeah. Okay. What happens if you write all this code inside the void loop? Void setup instead of void loop.
I guess there are like two functions. Voice setup is like just for like declaring things, and a void loop is for like running it again and again, again and again. Or else it will be just run once, red, yellow, green, then it will stop. So it's like quite like a recursive function.
Yeah, completely right. I still don't get the purpose of the last LED because if the system fails, like there'll be some power shortage or something like that, right? So in that
No,
case, your white
it's
LED
just
won't.
like not for like entire system fails if like an LED fails and stuff like that.
So how do you know
The
whether an LED is failing?
Like if in like this, okay, I actually took it for the entire system. Sorry, yeah.
So basically what we are doing, like if the button is pressed, so the LED stops blinking. So it just tells that the manual override has been taken over.
Yeah, that makes more sense. Okay, yeah, you can go
So
to the.
why,
Okay,
sir, I have a question. Like,
yeah,
why you are getting that sign at the top of these LEDs?
Which one, sir?
That one, uh, this black circle at the top of the LEDs.
We weren't getting it before. Sir. It's just to show that it's high, like it's 111, so it's
Okay,
high,
actually,
high.
I cannot see this. Okay, you can
Should
proceed.
I zoom it, sir? Oh,
No,
it's
this is not for eye.
okay. It's not one. I thought it's one. Okay, I don't know the reasons.
Okay, no problem.
okay, next week.
So, uh, this was how it looks. The next one.
Okay, so in this video we are covering the automated street light system using the LDR resistor. So in the circuit, basically once the light goes down, that means it becomes dark. So the LED starts glowing. That is the purpose of automation. So as soon as I place my hand, the LED street, the light street starts glowing.
Yes. So it has a basic implementation like when the analog input of the LDR goes below certain value, so it turns on the LED.
Okay, so you were using the LDR module, right?
The LDR resistor, sir, not the module. So we had a lot of constraints of getting the right material, and also there were some defects.
Okay, cool. Okay, so why do you think the voltage divider is required for your LDR?
So voltage divider. I didn't
Yeah,
get.
in case of making an LDR circuit, why do we use a voltage divider?
Voltage divider, sir.
Yeah.
So basically, if the because the when the light falls, a sudden there will be a flow of sudden current. So what I think is that the voltage division could probably send a specific value of input, like to avoid a sudden change. That is what I think.
Yeah. So some basically over if you place two resistors, so we want a maximum output towards one resistor, right? So
Right.
in order to have that, we use it. And like Was it the digital one which you were using, the LDR resistor, or
No, sir.
analog one?
Analog one, sir.
Okay, so what were the ranges you were getting?
So because at first I just took 1,000 only, and then later I realized that the LDR is also not working properly. So I made it to around 140. So it was ranging from around 160 to 100. The value was ranging from 160 to 100.
So, okay, when was it
That was basically
160 and
because of the defect, sir. At first, when it was above 1,000, so it was ranging from 0 to above 1,000, like 1,200 or 1,300, like that value
yeah,
it was ranging.
and like this question has been asked, but what would you do in case you are getting between 100 and 160? Because the accuracy will be too low for your system, right?
We
Uh,
can
s-
map that, I guess, using the map function.
Yeah. So how it works actually, like the map function. So like little bit what you understand from it.
Like we first give the value, then the initial range that we are getting, then to what value we want to like map it into.
Okay, and your basic principle of LDR, how does it work?
so a basic
Like
principle is that once light falls on it, its resistance becomes low. So current flows through it, and we take the input, and likewise we turn on the
and
LED
when the
or
resistance becomes low, then the conductivity will
yes.
increase and then the light will glow.
Yeah. Okay. Yeah. Harshit, anything? Tanisha.
No, you
Okay,
can
I
move on
will.
to the.
Okay, I will ask like a basic question. What do you understand from the difference between analog and digital signal?
So
Digital has like two extreme values, but analog it has a range of values in it.
Okay, what is the values of the digital signal in your Arduino Uno?
low
Digital
value,
Values.
low and
is
high.
two value, 1 and 0.
1 and 0, or plus 5
So
or 0?
What's up?
Plus 5 or 0, or 1 or 0?
1 or 0.
I'm asking like in term in the form of voltage.
Oh,
Yes, sir. And
voltage, sir.
voltage,
Like
yes, sir.
minimum volt, it will
No,
be 5,
yes,
sir.
sir.
Okay,
Yes, sir. It will be. Yes, sir.
that's fine.
so is it necessary like to use just 5 and 0 for your voltage to make it digital,
No,
or we
sir.
can do it other way?
Yes, sir. Because Arduino is taking an input of 12 volts, and we have two pins of 3.3 volt and 5 volt in the Arduino, so it can be modulated according to our preference, sir.
Okay, and in case I say you have like just your system is just like constantly giving out plus 5 volt, right?
Yes, sir.
So one will be like ground and other will be 5 volt. So how can you like just use that plus 5 volt and make it high and use not use 0 as low? You get my question?
So could you please repeat? I didn't
So
get quite
so
get it.
so consider LED for example. Okay, so if
Yes.
your value is high, it's glowing like it's. I'm just saying. Just consider it for this example. In case of an LED, if it's like positive 5 volt, it's glowing. In case it's close, it is not glowing, right? So we are
Yes.
saying it's high when it's positive 5 volt and 0 when it's not negative 0 when there's no voltage supply. So consider anything else that we can do in order to make high and low without using that 0 volt, like in normal scenario, not in term of Arduino.
So we can also like use the that we have a 3.3 volt pin, so that can also be used maybe.
Yeah, you're not getting my question, but what I mean to say is like you have plus 5 volt, right? So if you reverse the
Yes, sir.
polarity, it's minus 5 volt. In case it's a constant
Yes, sir.
supply, so plus 5 volt we can consider as high,
Yes, yes,
and the
yes, sir. We
minus
can
5 volt we
reverse
can
the supply.
consider it
Yes,
as low.
I get it. Yes, sir. We can reverse the supply. Then that can be considered as
Yeah,
a
it won't
low
work in
value. And
it won't
yes,
work in LED because of course like
yes, yes, sir.
you have cathode and anode, but yeah, in general. Yeah, you can move ahead with next video.
Sir, I have another question.
Yeah, yeah.
Okay, so in previous problem in your solution, you are using one register with the LED, right?
Yes, sir.
So, uh, is it possible like if I will not use that register, so can I use that LED with the Arduino?
Like for
Is it
some, it's possible, and the others will just burst away.
Yes, sir. We
uh,
practically experienced it. Like
okay? I'm
we
just
were
talking about
trying
this
to.
LED, this
No, sir.
LED in which
Which
We
we
one?
need
practically experienced
this
this. So
register.
we were
So is
trying
it possible?
to test all the
Like
LEDs. So
for white and red,
yes,
it
sir.
works. For green, it doesn't work. We
It
need
just
a
pops.
good resistance.
Yes, sir. We
Okay.
tried connecting it to the 5 volt. It just popped out.
Yes, sir.
So let's take this example ideally. Okay. So what I am saying that if I will give a plus 5 volt to that LED, then it will burst. So is it possible like if I will not use any external register,
Yeah, we can give it
but
to 3.3 volt water supply.
Yes, sir.
okay. So like do you know about internal pull-up register, pull-up or pull-down register?
No, sir.
Arduino Uno also contain internal registers. Okay, we can use those registers. Okay, you can continue.
Yes. In this video, we'll see the working of an automatic railway.
You can show the output first.
Okay, so it's getting loaded.
No problem.
Okay, so this is the ultrasonic sensor, right? Yes, sir, just a second. You have used ultrasonic sensor here, right? Yes, ma'am.
Yes, ma'am.
So, like, what is the principle that ultrasonic sensor use for calculating the distance? Like, it sends a trigger of like it sends a trigger of like high frequency. Then when it hits an object, then it receives the echo from it, and that duration that's taken, with that we can measure the distance. Okay. Like it basically echo means the speed of sound, so it uses the speed of sound to calculate the distance, right?
Yes, ma'am.
Yes. Okay, it's working now. We see the working of an automatic railway.
We can just
Show the
multiply with the
output.
time taken,
Yeah.
and we will get the distance covered, and we just need to divide it by 2.
I can show it in Tinkercad if you want and explain.
You can just show the output here only,
Yes.
Okay.
if its output is visible.
The output is not
Output
that
like
visible.
output from the hardware.
The gate starts closing its. Oh, for us, the ultrasonic sensor wasn't working, sir.
Yes, sir.
So
Yes, sir.
that's
We
why
had
we did
lot of
this.
issues, sir.
We had lot
Okay,
of
okay,
issues.
you can show the output of this Tinkerbell now.
Yeah. Go ahead with the Tinkercad.
Yes.
You can also show the practical, like what we did for it. There was a
Yeah,
arm
yeah.
in the end of the
Okay,
video.
okay. Let me just show
We made
the
it. Yes, the
Yeah.
hardware.
working.
The hardware was also there. Yes, sir, this is the
Yes, sir.
hardware.
We made
We
everything.
made the arm. The ultrasonic sensor is there. Yes.
Yeah,
So
but
the
it
arm
wasn't
was
working.
supposed to move by 90 degrees. So
So how is your servo rotating, like horizontally
yes,
or
sir.
vertically?
So vertically it moves up, vertically up.
Yeah.
From
So
0 to
yes, sir,
90,
it
then
was
back to
working also,
0.
sir. The server was fine. Just the problem with the ultrasonic
Ultrasonic sensor.
sensor. We tried
Is
two
it moving with the
ultrasonic
video servo?
No, sir, because the ultrasonic sensor
ultrasonic
isn't
sensor.
working.
Yes, so we could have done that, sir. Yes.
Okay, okay.
Okay. Just show your Tinkercad one only.
Yes, sir.
Only the output. So, did you guys collect these components from the cottage, right?
So
You got the components from the college, right?
yes, sir. That's that's what the problem. They were all very old, sir. So most of them were
Yes,
not
sir.
working. Even the
Not
Arduino
working.
was faulty, sir.
Even the Arduino
Okay.
was faulty, the one that was I was doing
Yes, sir.
yesterday. So
So
I
then
can
we
have to
went
do.
to school, sir, to get the components, and then we did there.
Okay, this is the one. So in here it's showing gate is closed. As the object is here like very close, so the gate is closed so that no car and anything goes by. Now if you take it away, now gate is opening, the servo motor has rotated.
and then it will show the gate is opened. And
Okay, that's fine.
then again, if you bring it close, again the gate is closing, and the light also glows when the gate closes, and it is closed the entire time. The light will be red, so that no car passes by.
Okay. Okay, good job. Okay, any other like solution of the other step?
Yes, another one we
So
could do only half, sir.
Okay.
Which one? The speed one.
Yes, sir, the
yes,
speed
because
one.
the ultrasonic sensor wasn't working. So
Was
Okay,
not
you
yes,
working.
can
sir,
present what you have
we
done.
So we
tried.
did it with the serial, and the LCD also wasn't working real
Yes,
live.
sir. Yes, we
So
got
we
it from
thought
the
of
institute
just,
only.
yeah,
So
we were just checking
we
on
were trying
serial
with that.
monitor.
You prepared the Tinkercad for that one? That statement?
Yes, sir.
So yeah.
Just a second. Yes, sir. So we did it without LCD, just within the serial monitor. Like it wasn't working, so we were trying out certain things here. So I don't know why it's not working.
Okay.
We can show you the video, sir, like that time that we took.
Yes, sir, we have the video.
Akash sir, so this is the last team or second last?
Oh, pardon?
Sister, this is the last team or the second last team?
There's one more. Abdul Kalam.
Last one.
So in this video, we are covering the speed measurement instrument using the ultrasonic sensor. So what we are basically doing is that we are calculating the distance, and through it we are calculating the
Output,
speed and the
show the output.
acceleration of the object near the ultrasonic sensor. So this is the object that we have used, and as we can see in the serial monitor that there is a change in the speed and the acceleration and also the distance of the object. And also we have tried to implement a model of this code, but due to some technical errors, it is not working.
Okay.
Oh, okay. You have any question, Harsh?
No sir. No sir.
Okay, it's okay. Yeah. Thank you for presentation. Yeah, it was nice indeed.
Yes, sir. Yes, sir. We could have
But
presented better, but there were some
yeah,
constraints. Like
Yeah,
we
yeah.
weren't able to. We got the materials yesterday only, and after getting the
where do
materials,
both of you stay? One is Shillong and the other one, Kalpesh. Where
Both
do
of
you
even
us
stay?
from
I
Shillong.
yes, both of us are from Shillong only. So we did
Okay.
together only. So we went to school
Actually,
and
there
did
is some
all these
problem with
experiments.
the delivery, like
Yes, sir. It got
delivery was
suddenly
Yes,
got
sir.
postponed.
delayed, sir. We were expecting the materials. We could have done it really well, sir.
Yeah, it's okay.
Okay.
You tried your best, and it was yeah,
Also,
good
if you want,
presentation.
sir, if the materials get delivered, we can show like after it is showing the delivery time to be 12, so we can do a proper presentation if you want.
The problem is like we have to decide the winner beforehand only. So yeah, you can do it, but yeah, it won't matter for this competition at least.
Yes, and also there was a constraint that we could have only met for a few hours only, sir. So what we got all the time we got was 3 to 4 hours yesterday and 3 to 4 hours today.
No,
That
today
too,
we were since morning. We
yes,
were
sir, we
in
were doing
school only.
in school only. So we went to
You have
school
done
and asked.
good job in this limited time.
Yeah,
We appreciate.
yeah,
Thank you,
it's a
sir.
good song. Thank you for the presentation. Last is Team Abdul Kalam.
Yes, sir. Good evening, sir.
Good evening.
I am Kanan Karthik from Abdul Kalam team.
Good evening. So yeah, present this screen and you can start.
And this is statement one. Sir, we done with push buttons and some with and traffic lights with automation. and the first one is controlled by push buttons. We arranged 3 push buttons. If we press the first push button, the red LED will glow for 10 seconds. Hi to all. I'm from Ultrasonic Sensor Ldr. First power statement given to start and will demonstrate my experiment. Yes, 3 LEDs.
Show the output. Okay, okay.
Yes, sir. When I press this push button, the red LED will glow for 10 seconds. And after 10 seconds, I need to press the second push button. Then green will glow for 10 seconds. And next followed by yellow, sir. This is using push button, sir. And we also
Okay.
made which works on time delays, which was given in code.
Okay, second one.
Sir, here first red LED will glow for 10 seconds, and then green will glow for 10 seconds, and then yellow will glow for 10 seconds, sir. We given time delays in code.
Okay.
Yes, sir. On serial monitor, it will print a stop when it's red, and it will print go when it's green, and it will print wait when it's yellow.
Okay. Sir, any question?
Okay, so what will happen if you reverse bias the LED?
Sir, if you reverse the
You change the
LED,
polarity of LED, what will happen?
sir, the LED will diffuse, sir. Means
It will not work, sir.
And
the
any explanation why does it happen?
sir, LED have a fixed polarity, sir. The longer one is we should connect to positive, and the shorter one we need to connect with to ground, sir.
No, you have done this part in your basic electronics, right? In first or second year.
Yes, sir.
So what will happen? Like LED is also a diode. So what will happen if you will connect a diode in reverse bias? Will it work?
It won't work, sir, because the separation between the PN and N junction diode, P and N will become more, sir.
Okay, that's what.
Yeah.
Okay.
Okay, yeah. Go to the second task.
This is a statement 2. Sir, this is a LDR sensor. With the help of LDR sensor, we are detecting the presence of light surroundings. If there is a light in our surroundings, then the LED will turn off. If there is no light, means it's dark, then the LED will glow, sir. Sir, now there is no light falling on the LDR. So the LED is glowing, sir.
So you are using our digital module, right?
Yes, sir, digital monitor module.
Okay. Okay, that's it. Sir, any question?
No, it's all right.
Okay. Proceed to next.
Sir, this is a railway gate, sir, but our servo motor is having some malfunction. It's not working as mentioned in code, sir. That's why we put in gates.
Okay. So
But
which servo motor you are using? 180 degree or 360 degree?
360 sir.
360.
Yes, sir.
Okay. Okay. So
Sir,
sir.
it is not working, sir.
Okay. Okay. I can
Yes.
understand.
It is
So you are
operating.
using a servo.h library, right?
Yes, sir.
So is it possible, like, can we operate this servo motor without using that library?
Yes, sir. We can do, but we need to define some functions, sir. Like um,
Okay,
my servo dot write. We need to define that function.
okay, okay. So this model is working or not?
The servo motor is not working, sir.
Okay, you can show the output, no problem. What you are getting.
But whether the gate is closed or open, it is indicated by two LEDs, sir. If the green LED is glown, the vehicles can pass through the road, sir. If red LED is glown, the gate is closed, sir.
Oh, okay, okay, okay. So, sir, any question?
No, you can move ahead.
Sir, here we are using ultrasonic sensor and finding distance between the object and the speed of object and acceleration of the object, sir.
Okay. Okay. What about the readings? Like, we can check the readings. Acceleration, speed, distance.
Sir, can you please repeat? I can't hear you.
Okay, no problem. You have done all this problem solution on LCD also, right?
Sir, our LCD is not working, sir. We have connected as all the
Which
computers
module do you have? That
LCD
shield
keypad
or
shield.
normal module?
LCD keypad shield, sir.
Shield. Okay.
Sir, we also see in website, sir, the functioning of it, sir, but it is not working, sir.
Okay.
The
Okay.
basic pins, etc.
What you
You
have
did it
done? Yes.
Tinkercad or something like LCD?
No, sir, we didn't did done in Tinkercad. We doesn't have that much time.
Okay. Yeah, one last question. Like, in case you are measuring the speed of a car, right, with your ultrasonic sensors, what if we want to measure speed of a car in a sharp turn? Do you understand? Like, for
So,
instance, like not exactly 90-degree, but if the turn is, for instance, like 75-degree, right?
Yes,
So
sir.
how you gonna place the ultrasonic and how you gonna measure the speed of your car?
Sir,
Did
we
you
will
get my question?
yes, sir. Sir, if this is the turn, then we will place our ultrasonic sensor here, sir, which will detect the object in this conical area, sir.
So you like, how do I explain it? Right, if you place your ultrasonic, how are you gonna place it? You showed with the cursor. Can you do it again?
Yes, sir. Sir, if this is the curve, then we will place that ultrasonic sensor here, sir, at the place of my cursor.
And if the your ultrasonic is placed in an angle to the car, how are you gonna measure the speed then?
Sir, then we need to do modifications in our code.
Now, what kind of modification we are talking?
Sir, first we need to know what is the angle between the car and the ultrasonic sensor. Then we
Yeah.
will use uh, means we will divide the components are v cos theta and v sin theta in x and y directions.
Okay. Yeah.
Using the
Yeah.
principles of physics, we can do that.
Okay. Yeah. Good. Harshit.
No, sir. No.
Yeah.
Good job. Like, you have explained very well that last problem.
Yeah.
Like how
Like
we
that,
can
shield
connect.
is worked good. We can do more.
Okay, no problem. No
You
problem.
were trying with Shield, right? Right.
Yes, sir.
So what was the problem that was coming with Shield?
Sir, when all this we connected all the
Have
PLC
have you
very connected,
tried
but it's not working.
have you tried the Shield just keeping on the Arduino? Like you can just directly plug it to the Arduino.
Yes, sir. I plugged into Arduino, but it's not working, sir.
Okay, the Shield was not working.
Yes, sir. It's not glowing, sir.
Okay, just return that set. Okay, you
Yeah,
will get
yeah,
0.1.
definitely return that.
Okay,
All
sir.
right, all right. Yeah, nicely done. Like, I feel from the expectations that we had, you guys have done much
I,
more far better
Yes,
than
sir.
that.
Yes, sir.
yeah, yeah. And in case like anyone has what do you call it, broken components or equipments, you should return it. Okay, like the
Yes, sir.
event is over, so you
Yes,
can
sir.
return it. So yeah, it was a good presentation, and everyone's participation was very good. We weren't expecting so much, but yeah, you were able to tackle. Most of you were able to tackle it, and due to some lack of components, I do see like some other team had suffered. But let's see how we'll decide the result. We'll just let you know in the WhatsApp group only, like the result.
Yeah, it
So
might
yeah,
take time a bit.
yeah,
Like
yeah.
we'll be analyzing all the code and all
So
the things that
yeah,
you have done, and
so
then
so
only we'll be creating the final
yeah,
result.
your codes will be gone through, and like the cleaner code and like the function driven code will be like given the preferences. And yeah, we can take time because like we have to conduct this event for the third year as well, so it might just take 1 or 2 days, or we can do it later. I don't know, but yeah, your videos will be seen and your code will be gone through, and this presentation will also be taken care of.
Yeah, yeah. Any other open endpoints that we have, or any doubts?
Yeah, anything you wanna like put forward, any feedback, anything is open.
Yeah, we are good to go. All the best, guys. You guys
Yeah,
have really done a
yeah,
nice job.
excellent job. Thank you, everyone.
Thank you.
Okay,
Thank you,
so
sir.
you guys
Thank you,
can
sir.
Thank you, sir.
leave this meeting.